most popular treatments to ease pain is to use cold packs. Do you know how these cold packs work? In fact, the process of making cold pack is not a chemical reaction. A mere physical process called dissolution happens here. Inside the cold pack, there is water and ammonium nitrate. When you heat the cold pack, the solid ammonium nitrate dissolves in liquid water. This dissolving process is endothermic, that is, requires absorption of heat. When heat is absorbed from the surroundings, the pack feels cold. This is an application of solubility of solids in liquid. In this video, we will discuss the chemistry of solubility of solids in liquid. Broadly, solubility is defined as the maximum quantity of solute that can dissolve in a certain quantity of solvent at a specified temperature or pressure. In fact, it is a property of a solute to dissolve in a solvent to give a solution. Solubility arises from the interaction between particles of solute and solvent. This indicates solubility depends on the nature of the solvent and solute, temperature and pressure. However, here we are discussing the solubility of solids in liquids, and it has to be noted that solubility of solids in liquids is independent of pressure. It depends only on the nature of solvent and the temperature. Let us first discuss how nature of the solute and solvent affect the solubility. Here you can see sugar dissolves in water, whereas naphthalene does not dissolve in water. Do you know why? In general, a solute dissolves in a solvent if the intermolecular interactions are similar. Or in other words, you can say like dissolves like. That is, a polar solute dissolves in a polar solvent. That is why non-polar naphthalene remain insoluble in polar water. That is, polar or ionic molecules like sugar or sodium chloride are soluble in water. The solubility of ionic or polar solutes in polar solvents is due to the electrostatic interaction between molecules, whereas the solubility between non-polar solutes and solvents are due to similar solute-solute, solute-solvent and solvent-solvent interactions. When a solid solute is added to solvent, the solute dissolves and its concentration increases in solution. This process is known as dissolution. If you continue adding the solute, a stage is reached where no more solute can be dissolved. At this stage, a dynamic equilibrium exists in the solution. At this time, some solute particles in solution collide with other solid solute particles and get separated out. This is known as crystallization. In the state of dynamic equilibrium, the number of solute particles going into the solution will be equal to the solute particles separating out. That is, the rate of crystallization will be equal to the rate of dissolution. Also, at equilibrium, the concentration of solute in solution will remain constant under given conditions of temperature and pressure. Such solutions in which no more solute can be dissolved at the same temperature and pressure is called a saturated solution. On the other hand, if you can dissolve more solute at the same temperature, then it is called an unsaturated solution. Or you may say the solution is in dynamic equilibrium with the undissolved solute in the saturated solution. It contains the maximum amount of solute dissolved in a given amount of solvent, and the concentration of solute in such a solution is its solubility. Next, we will see how temperature affects the solubility of solute in a solvent. Consider the process of dissolution as the formation of new bonds between solute and solvent. During this process, heat is liberated, and if the heat liberated during the dissolution is greater than the heat required to break the bond between the solutes, then dissolution is termed exothermic. Here you may represent the dissolution process as solute plus solvent giving solution plus heat. Then, according to Le Chatelier's principle, if you increase the temperature, it will favor the backward process. This indicates dissolution is not favored. As heat is already produced in the system, increasing temperature will decrease the solubility. For instance, solubility of sodium carbonate and cesium sulfate decreases with increasing temperature. On the other hand, if the liberated heat during dissolution is less than the heat required to break the bond between solid solutes, then dissolution is endothermic in nature. According to Le Chatelier's principle, if you increase the temperature of an endothermic process, it will favor forward reaction. For example, solubility of sodium chloride, sodium nitrate and potassium nitrate increases with increasing temperature. As mentioned earlier, solubility of solids in liquids is independent of pressure. This is because solids and liquids are incompressible with increasing pressure. However, solubility of gas in a liquid depends on pressure. Can you tell me how pressure affects the solubility of a gas in liquid? We'll discuss this in our next video. Now, let us summarize what we have learned today.
Manorama Horizon. Learning made simple.